So now we graph it and it'll be y.
Now we graph it and it'll go, let's see, here's my 1/2 negative 1. Here's my 1, 0. And then here's my 2, 1. It's got to snuggle up to the y-axis the way the other one snuggled up to the x-axis. Where exponential growth seems to go almost straight up. This needs to seem to go almost straight to the right.
It looks like a martini glass sideways.
It does look like a martini glass sideways.
Wait,
And if we draw the y equals x line that's a reflection, it has a stir sticking straight up in it.
Wait, doesn't that cross?
Perhaps held by an olive.
Doesn't that cross x equals 0?
Doesn't that cross x equals 0? No, I have it, x equals 0 is the y-axis. Okay, so it doesn't cross its asymptote. Good question. I feel like the olive is staring at me. Okay, so now we're going to do some very simple shifts of this. And for tonight's homework, let me double check before I say this. No, there is a little bit of a change. Okay. All right. Same rules for shifts apply. You will be able to use your calculator to help with these graphs. So I want them to look extra good. And okay, now it's a different basis. Okay. All right. Domain and range. You guys remember what domain and range are? Sort of.
There's something to do with
I
graphs.
recall us being taught this, but I don't
All right, I'm glad you've heard the words.
They have something to do with graphs.
It has something to do with graphs. Okay.
Yes.
Let's see. Let's review this quickly. Okay. Domain is all possible x values on any particular graph.
I need a drink of it.
Okay. Range is all possible y values on any particular graph. Okay? Picking up the green marker. So I'm going to talk about y equals 2 to the x for a second. What are all the possible x values of y equals 2 to the x? Looking at the graph, are there any x values that don't exist? Or can x just go from negative infinity all the way to positive infinity? Looking at this graph, it goes up forever over here, snuggles up to the x-axis forever this way. Look, tell me something about its domain.
Oh, that's the one with the infinity sign, right?
Yeah, it's using infinity sign. If you think it goes all the way to infinity in both directions.
Doesn't it?
Yes, Marissa's got it.
Up and left?
The domain goes from as far to the left as you feel like imagining to as far to the right as you feel like
Can you
imagining.
write that again?
Bracket, negative infinity, infinity. Now the brackets means
Which side with it? I know.
the infinity or the bracket parties.
No, what's confusing is how do I indicate that it's supposed to be going up and then I'm supposed to be going left? Wouldn't the positive one be going right?
Okay, excellent. Domain is just values along the x-axis, so it only concerns itself with left and right. And then range only concerns itself
Oh, yeah.
with up and down. Okay? Now, the range on this, can this y equals 2x graph, looks like an airplane taking off, does this exist for every y value you can imagine? No. It doesn't exist for negative y's at all. It doesn't start existing until you get above the x-axis. Now, when you have an asymptote, the asymptote is not part of the domain or range. Okay? This function can't actually be 0. Y equals 2x can't be 0. Can't get down that low. It doesn't touch the asymptote. Well, you could guess with it, but here's what you actually do. This bracket means not including the last point. If I use a parentheses, it means including the last point. Okay, but for these, you'll only be brackets because they won't include it. So if I put this bracket and I put a 0 here, that means the range starts barely above 0 but doesn't include 0. Okay, does that make sense? And then this graph can go up forever, so it can be infinite. That's not a problem. I'm switching to the blue marker. That means I'm talking about the inverse, x equals 2 to the y, or at y equals log base 2 of x. Same thing. I'm talking about the domain first, the blue graph. For what x values do you think that exists? Only ones to the right. Marissa's got this down. There are no negative x's that show up as values that correspond to this graph. There's no negative x's with the blue graph above or below them. So we start just after 0, and we go out to infinity. What about on the y-axis with the range for this one?
They're both infinity.
They're both infinity. So we say from negative infinity, which is down here as far as we can imagine, up to positive infinity, which is up as high as we can imagine. Okay, so that's how the asymptote, the domain, and range get affected on these things. Now, shifts work the same way. If you have f of x equals the log base any number, x minus k plus h. And I don't believe we'll be dealing with any coefficients on the homework tonight, so there's no a. I don't see any. Okay. What does k mean? What does k tell us to do? Something.
Right to left. Shift it.
Yep. Counterintuitive. K for counterintuitive, which I can no longer spell.
Why is it a C?
It should be, actually. Counterintuitive, left or right. H is intuitive, up or down as usual. Keep in mind this also moves the asymptote. Okay? Now, I recommend you use your calculator and your trace button tonight. If you don't use your calculator, if I make you do some no calculator graphs, the way I would do it is this. Well, you know what? Use your calculator and trace button tonight. Tomorrow we'll go over some how to do this without a calculator and how to find the inverse. For those of you who struggled with what I meant by parent function last time, that will be difficult. So I want to spend some more time on it because it involves going back to the parent function. I think I've given you enough information to get through the homework.
What is the homework?
And the homework is, thank you, it's page 490. '46 to 78 even. And please get started on it. I want to see you struggle with this in my presence.